Hello children, welcome to EDUHUNT classes where you can excel your academics. In this video, we are going to learn about general properties of acids. What are the general properties of acids? In the previous videos, we already discussed regarding the physical and chemical properties of acids, yes? So in this clip, we'll learn clearly about the specific general properties of all the acids. Okay children? Okay, let's start the session. Are you ready? Yes, here we go. General properties of acids. Okay, yeah. So in this general properties of acids, we have namely 10 main general properties of acids. Okay, namely, first one is about taste. Second one, effect of indicators. Third one, effect on skin. Fourth one, effect of electric current. Fifth one, action with metallic oxides. And sixth one, action with metallic hydroxides. Seventh, action with metallic carbonates. And eighth, action with metallic sulfides. Ninth one, action with metallic sulfides. And 10th is action with active metals. So these 10 we are going to learn in this particular video. Don't miss and watch a clear video full length. Okay. So here we have namely taste to action with active metals. Children, one more difference. Look at the 8th and 9th points. Here we have a small key difference. It is 8th one is action with metallic sulfides, T. Okay. And here action with metallic sulfides. The difference is T in the 8th point and D in the 9th point. Okay. These two names are different. Okay. Don't think it is same. It is different. Okay. And let's go one and one. First one is taste. What do you know about the acid taste? How do acids taste? Do you ever taste in time? No, right? So, yeah. So, yes, did you taste? Then what are the acids called as? Those acids which we are intaking daily are called as organic acids. Very good. So, those are safe to, swallow, eat, taste. Fine. What's the taste of the acids, children? For example, orange, lemon, amla, all these are? Yeah, very good. There's a sour to taste, yes? Sour in taste means what? Pullaga untai kada? Yes. So here we go one by one. The first general property of acid is about taste. See, taste. Acids have sharp, sour taste. Okay, acids are clearly having sharp, sour taste. Okay, pullaga untai, all acids. Fine. Yeah. Now, what is the second property, children? Effect of indicators. So, how these acids are derived? By some indicators, we can say acids are present in that particular liquid. We'll see how these are indicating toward which colors. We'll see here, okay? Effect of indicators. Here we go. The substances which are used to identify acids. To identify acids or alkalis due to the change in their color. Change in their color అంటే రంగు మారిపోతాయి అన్నమాట. Okay, are called as indicators. So what are indicators, children? If we take a suppose a colorless liquid, children, we want to know that it is an acid or a base. Alkali means what, children? It is a base. The word alkali means base. Okay, here alkali is no bases. You can write down here. Okay, children. So here in that particular condition, they'll add some different colors as indicators. So if the color is changing to any subject color, specific colors, then we can say it is an acid or as a base. Okay, children, that's the color indication and we call them as indicators. We call them as indicators. Yes, indicate chestai color ni. Okay na? So dan batti మనం ఏం చెప్తాము, అది acid or base అని చెప్పేస్తాం. Okay, right? Now here we go. The first point is acids turn blue litmus paper into red. We know this already. We discussed all these things. Okay, so acids will turn blue litmus paper into red. So that is indication of an acid. So blue red is an indication for acid. So blue litmus into red litmus paper. If it is turned in that particular liquid, that liquid is said to be an acid. Okay, clear. Now second point. Acids turn methyl orange solution into pink or red. Okay, methyl orange is generally some orange, dark orange in color. If I pour that indicator of methyl orange, one bottle is there, children. If I add some 2 or 3 drops to that of particular acid, it will change into pink or red in color. Okay, that's indication of an acid. Fine. Now third one. Okay, here we go. Acids turn alkaline pink phenolphthalein in aqueous solution colorless. So what happens? If I take pink phenolphthalein, phenolphthalein is pink in color in that conditions. Okay, if I add that drops into that particular acid, it turns colorless. So the pink will be disappearing. Okay, so that is also indicators regarding the acids. So what are three? One is litmus paper test, other one is methyl orange, other one will be phenolphthalein. So these three are acting as an indicators. We have so many, we have turmeric, all these things are there, but those are organic one. Here we have, this will be testing in the laboratory specifically. Okay children, this is all about the first and second general properties, taste and effect of indicators. Okay, once again for you, indicators, what are indicators children? Those substances which are used to identify the acids or bases. Okay, so how they'll identify? They'll easily change their color. Easily changing their color, they'll specify us whether it is an acid or a base. Clear children? Very good. So those are named as indicators. Fine. So now moving to next general property, effect on skin. Children, you already know acids are very dangerous. Mineral acids, like specifically inorganic acids are there, no? Organic acids are something we are intaking them daily, fruits, vegetables, etc, etc. Yeah, tea, coffee, all those things. But what about, there are other specific acids, what are they? Mineral acids are also called as inorganic acids, right? So those acids are laboratory acids and they are not safe to intake, and also in the presence of, you should not affect on the skin. What happens if you add 2 or 3 drops into your skin, on your skin, what happens? It will burn, it cause some burns, right? Corrosive in nature, right? So here it is the point, general property of that. I will be repeating again over here. Effect on skin, what happens here? It is a strong, some mineral acids, okay? Not all. Some strong mineral acids are there, no? Those things, okay? Yes. Strong mineral acids have corrosive action. Which action children? Corrosive action on skin. Means what? Mantaga burn అయిపోతుంటది మన skin. So మనం ఒక కొన్ని drops వేసినా సరే ఏమవుతుంది? అది మంటగా burn అయిపోతుంది skin. So that is all about a strong mineral acid. But you had a few drops of orange juice, it doesn't mean any change ఏమీ అవ్వదు. Orange juice వేసినా లేకపోతే లెమన్ చేతిన పిండుకున్నా ఏమీ అవ్వదు. Those are organic and safe acids. But these inorganic acids are strong in the sense mineral acids kada. Avi laboratory acids kabatti they are safe. Are they safe? No, they are not safe. Okay, so strong mineral acids have corrosive action on skin, so they are not safe to touch and also should not apply on your skin. Okay, you have to wear gloves and all during laboratory scenes. Okay, so it causes painful burns. Mantaga untai kada, they causes painful burns, bubble chestai laga chinnaga. Okay, should not ever play with that particular inorganic acids. Okay children, enough. So we have specific indications of the colors here also. Listen, concentrated CONC dot means we have two, no? What are the two? CONC dot means that is called as concentrated acid. Very good. Concentrated acid means what? More amount of acid, less amount of water. Very good. If it is written DIL dot, what happens? What does that mean? Yeah, it is called as dilute acid, which means more amount of water, less amount of acid. Very good. So here we have children CONC, which means concentrated. Okay, very good. Concentrated acid. Which acid is that? Concentrated sulfuric acid is taken over here. Formula? Sulfuric acid formula? H2SO4. Very good. So concentrated sulfuric acid stains the skin black. Okay, remember that. If you add some concentrated of sulfuric acid drops on your skin, what happens? It will turn your skin into black in color. Okay, remember that. Fine. Now next one, concentrated nitric acid. What's the formula children? Nitric acid, remember or not? Nitric acid formula. Very good. HNO3. HNO3 is the formula for nitric acid and it turns the skin yellow. Okay. If I add few drops of concentrated nitric acid on my skin, what happens? After burning and all, what happens? It will turn my skin into yellow in color. Fine. Now, third one. Concentrated hydrochloric acid. What's the formula children? Very good. HCl. Okay. Concentrated hydrochloric acid stains the skin into amber color. What is the color, ma'am? Amber color. Amber means it is a warm. Amber means it is a warm. And we can say radiant. And it is a color between yellow and orange. Between that, okay, we can write the color is between yellow and orange. That is known as amber color. Which color, children? Amber. Okay, fine. So we have here three, no? What are the three? Concentrated. The representation is like this, children. Okay. Okay. Concentrated. What's the first one? Concentrated sulfuric acid stains the skin into which color? Black in color. Very good. Next one. Concentrated nitric acid stains the color into, stains the skin into yellow in color. Very good. Now, third one. Concentrated hydrochloric acid stains the skin to which color? Amber in color. Amber means between which and which color? Yellow and orange in color. Very good. This is a warm radiant color, children. Okay. Now, this is all about the effect on skin. Now, it is written as here, if you see here, children, there is a word called strong mineral acids, right? Strong, especially strong mineral acids have corrosive action on skin, okay, because it causes painful burns, right? Here, one main note point is there to be noted. What is that? Let's see. All mineral acids are not corrosive. Because why? Only strong mineral acids are corrosive, not all mineral acids, which means there are some weak acids also, no? Those weak mineral acids are safe, okay, not that much effective on the skin, okay. For example, carbonic acid. What is that, children? Which acid is that? Carbonic acid is used in making soft drinks. Hey, we already discussed this carbonic acid, no? Did you find that? Carbonic acid? Did you write the formula over here? Formula is H2CO3. So, carbonic acid is written as the chemical formula H2CO3. So, this is used in making soft drinks such as beverages like say cola, lemon lime soda. So, all these are having the particular acid called as carbonic acid. Formula H2CO3, right? So, here we have effect on skin. We have strong mineral acids which are corrosive in nature in the sense on the skin, and also it causes painful burns when effect on skin, okay, but not all mineral acids are harmful. There are some mineral acids weak which are called as carbonic acids, and those acids are used in making soft drinks, okay. Remember the word strong over here, okay. Only strong mineral acids are corrosive on skin, corrosive in nature, fine. Now, moving next general property of an acid, that is effect of electric current. Effect of electric current. Now, see what happens. All aqueous solutions of mineral acids are good conductors of electricity. Here, what is called as mineral acid? What are called as mineral acids, children? All inorganic acids are called as mineral acids, because we have other name of inorganic acid. What is that? Mineral acid, right? So, mineral acids in aqueous solution case, they are acting as a good conductors of electricity. They are acting as good conductors of electricity, and they decompose with the liberation of hydrogen at cathode. So, at cathode, okay, we have to know cathode anode. In that cathode, we are leaving the particular hydrogen in the particular cathode. In that particular, the reaction, okay, the aqueous solution, they decompose, the acids decompose with the liberation of hydrogen, because acids do contain the particular hydronium ion, no, hydrogen ion, yeah, that one. So, they liberate the particular hydrogen at cathode, fine. Now, this is all about effect of electric current, and moving to next one, that is, yeah, the main reactions. Action with metallic oxides. How these acids are acting with the metallic oxide, let's see over here, okay. Here, all metal oxides react with dilute mineral acids to form their respective metallic salts and water only. Children, one more important point to note here, it is dilute in the sense, yeah, representation DIL dot. So, DIL dot mineral acids. What is the meaning of mineral acids? Yeah, inorganic acids. Very good. Inorganic acids called as mineral acids. Inorganic acids. Then what about dilute, children? Dilute in the sense more amount of water and less amount of acid. Okay, that is the meaning for dilute. Okay, children. Now, so what happens? Action with metallic oxides. What is going on? All metal oxides react with dilute mineral acids to form their respective metallic salts. Okay, and water only. Fine. We'll see the reaction over here. Fine. So, metallic oxide react with mineral acid, which is dilute in condition. DIL means dilute in condition, gives rise to metal salt, metallic salt, respective metallic salt, and also it is giving water as the only products. So, this is the reaction children. The reaction arrow mark is like this. Okay, the arrow mark. So, the arrow mark's left side things are called as, see, left hand side. I'll dot over here. Wait. See, this is arrow mark, no? If I represent these two, these left hand side are called as reactants. Left hand side things are known as reactants. So, these both are reacting to give the right hand side products. RHS means right hand side. Okay. So, just see the arrow mark over here, children. If the arrow mark is there, yeah, it's there. Fine. Arrow mark is there, no? So, arrow mark left hand side is called as reactants. These both react to give these both products. Arrow mark left hand side, right hand side. Left hand side it is reactants, right hand is it is products. Okay, children? This is the chemical reaction going on here. Okay. So, when metallic oxide reacts with mineral acid, we can say dilute mineral acid, it gives rise to, you can use the word here, gives rise to, yeah, metallic salts and water. Once again, metallic oxide react with, yes, mineral acids, dilute conditions, mineral acids. It gives rise to metallic salt and water. Like that, you have to read particular things. Okay, fine. Yeah, we can write representation plus in the sense reacting none. That's it. Okay, fine. Now, here we have the particular examples for you. Examples number 1 and example number 2. So, what is example number 1 and 2 we are talking about? The specific indication of the particular point itself. Okay. Here we have taken Na2O reacting with 2HNO3, dilute condition giving rise to 2NaNO3 plus H2O. So, shall I write the names, children, for you? Shall I? Yes, I'll write for you. Wait. Okay. So, here Na2O is called as sodium oxide. What is that? Where shall I write? Shall I write up or down? Okay, write here only, fine. Sodium oxide. Na2O is named as sodium oxide. Okay, repeat after me. Sodium oxide. When sodium oxide reacts with this 2HNO3 is there. Now, what is HNO3 name? Which acid is that? Yeah, the strong acid. What is that? Very good. Nitric acid. Okay. Nitric acid gives rise to, what is this? Metallic salt, no? Which metal is there? Sodium metal. So, sodium. Sodium nitrate. And finally, what is that? H2O means water. Very good. Now, I'll read the reaction. I'll read it out for you. Okay. I'll read it again. See. Sodium oxide, when reacts with 2 molecules of nitric acid, dilute condition, it gives rise to 2 molecules of sodium nitrate and water. Fine. Like that, you have to read the particular reaction, children. Fine. Once again, sodium oxide reacting with 2 molecules of nitric acid gives rise to 2 molecules of sodium nitrate and water. Okay. Represented in the chemical formula, Na2O plus 2HNO3, dilute condition gives rise to 2NaNO3 plus H2O. Clear now? Very good, children. Now, next example for you. It is copper oxide, CuO. It is copper represented 2 here because of the valency. Okay. Copper 2 oxide reacting with, you know this, no? H2SO4. What is H2SO4? Yeah, very good. Sulfuric acid gives rise to copper sulfate. Copper sulfate. And you know what is H2O? What is that? Finally, water. Water. Okay, clear enough? So, CuO plus H2SO4 in dilute condition, it gives rise to CSO4 plus H2O. Okay, Once again, copper to oxide, the names now. Copper oxide, you can read copper oxide. Copper oxide reacts with sulfuric acid, which means dilute sulfuric acid, okay. Copper oxide reacts with dilute sulfuric acid. It gives rise to copper sulfate plus and water, okay. So, let's the representation of chemical formula as well as with the names I have given you, children. Clear, no? There's no doubt for you, right? Clear, right? Okay. So, these are the examples and with the actions of action with metallic oxides, children, okay. So, here we go with the particular things. Clear, no? Metallic oxide plus mineral acid, dilute condition, we are giving rise to metallic salt plus water. This is all about action with metallic oxides. Hope you did clearly understood regarding this, okay. Examples also give the names. Fine, children? Yes. Next one. What is next property? Next general property. Action with metallic hydroxides. Action with metallic hydroxides. Before it is action with metallic oxides. Here it is extra word. What is this? Hydroxides. Okay. Now, all metal hydroxides react with dilute mineral acid. Same. There is the word oxide. It is hydroxide. Simple. To form their respective salts and water only. Similar, children. Metal hydroxide plus mineral salt gives rise to metal salt plus water. That's it. Clear now? Examples. In the place of oxide, they gave hydroxide. That's it. No more confusion. Okay. Remaining all the same, right? Yeah, very good. So, here, what is the name of NaOH? NaOH. Sodium hydroxide. What about COH twice? Copper hydroxide. Children, before slide, it is all about oxides. Here it is hydroxides. Okay, hydroxide sense it is a purely basic hydroxide. No, if you see any word called hydroxide, which means OH minus, that is a base. Okay, hydroxide means it is a base. We can say OH minus representation. Okay, we'll talk about the basic section. Okay, now sodium hydroxide reacting with. Okay, once again with the formula one. Okay, first one. NaOH reacting with HCl. Okay, dilute HCl gives rise to NaCl plus water, H2O. Now, second example. COH twice reacts with dilute H2SO4 gives rise to CSO4 plus H2O. Fine. So, what's the name of the particular NaOH written over there? Sodium hydroxide. Now, it's your turn, HCl. What is HCl? Very good. Hydrogen chloride. Fine. Now, what is NaCl? Very good. Metal salt. Which metal is that? Sodium metal. So, sodium. Cl means chloride. Now, what is H2O? Yeah, easy. Water. So, sodium hydroxide reacting with dilute hydrogen chloride giving rise to sodium chloride and water. That is the reaction going in the metal hydroxide. So, when an acid is reacting with metal hydroxide, gives a particular metal salt and water respectively. Okay, children? Yeah. Now, second example. Copper hydroxide reacting with H2SO4. What is H2SO4? Yes, it is sulfuric acid. So, when this copper hydroxide reacting with dilute sulfuric acid, it gives rise to particular metal. What is that metal salt? Yeah, it is copper sulfate and 2 molecules of water. To balance that, we are representing 2. Okay, to balance the equation, we are writing 2 over here. Okay, why not here means not required. We have Na1 and here Na1 particular thing. And 1 O and 1 over here. Okay, 2 hydrogens, 1 and 2. Here 2 hydrogens. Fine. Now, Cl. So, all it is balanced in the particular first example. So, not writing any numbering. Okay, but down we have some shortage of H and O. So, we are representing with the number 2 in the before one. Okay, to just balance the equation and in this 2. Okay, but while reading, you have to read like this. copper hydroxide reacts with dilute sulfuric acid, gives rise to copper sulfate and 2 molecules of water, or else just water. Fine. Clear now? This is all about action with metallic hydroxide. Everything is similar, children, but there is one small difference. It is hydra. Hydra, what is there? No, hydro. This word is adding HYDR. Before one is oxide, it is hydroxides. Okay. So here briefly, if you see, when acid is reacted with base, it gives salt plus water. It is a neutralization reaction. What is neutralization reaction? When acid reacts with base, it gives rise to salt plus water. That is a which reaction? That is neutralization reaction. Which reaction, children? Neutralization reaction. Fine. So when acid and base reacts, it neutralizes to salt and water. Okay, that is called as neutralization reaction. Same happened over here. Acid plus base gives rise to salt plus water. That's it, no? So here we have completed some things regarding taste up to metallic hydroxide. In the next video, we'll watch regarding the other thing. Okay. Okay, this is all about action with metallic hydroxide. So up to here we cleared 6 general properties and remaining 4 will be coming in the next video. Okay, go watch over there. Thank you.